In this video, I will show how to use the fundamental theorem of calculus to evaluate the definite integral. First, let me remind you what the fundamental theorem of calculus is. It says that if you're looking for a definite integral of a function on the interval from a to b, you have to find the antiderivative of that function and then evaluate it at the upper limit and then subtract the value at the lower limit. So this is the fundamental theorem of calculus. So in order for us to continue with solving this definite integral, we have to first find the antiderivative of this function. To find the antiderivative of this function, we can just use the power rule, which says that the integral of x to the n is 1 over n plus 1 times x to the power n plus 1 plus c. And using this power rule, we can find the antiderivative of our function. We can simplify it a bit further. So the antiderivative is 1/2 of x to the 4 plus 1/2 of x squared plus c. So now, if we're going to use the fundamental theorem of calculus, we have to write the antiderivative here. So this is the notation that we use. We notice how we write the antiderivative without c because it will cancel anyway, so we can save some time by not writing it. And we draw the vertical line and we put the lower limit here and the upper limit here. That means next I'm going to plug in the upper limit into the function and then subtract the value of the antiderivative at the lower limit. And now evaluating this arithmetic expression gives us the following. The first set of parentheses is 2 to the 4 is 16, 16 over 2 is 8. 2 squared is 4, 4 over 2 is 2. And now looking into the second set of parentheses, we have negative 1 to the 4, it's 1. So we have 1/2 plus 1/2 times negative 1 squared, which is also 1/2. So 1/2 plus 1/2 is 1, 8 plus 2 is 10. So we have 10 minus 1, 9. So the answer to the original question is 9.